Show that log 10 of 10x squared equals 1 plus 2 log 10x. Show that the graph of y equals 2 log 10x can also be transformed into the graph of this, y equals 1 plus 2 log 10x, by means of a stretch, and describe the stretch. The curve with equation y equals 1 plus 2 log 10x intersects the curve with equation y equals log 10 of x squared plus 1 at the point P. Given that the x-coordinate of P is positive, find the gradient of the line OP, where O is the origin. Give your answer in the form log 10 of A over B, where A and B are integers. So let's have a little look at this then. First of all, we need to show this, part 1. So log 10 of 10x squared times you add, don't you? So it's log 10 of the first part of the product plus log 10 of the second part of the product. Power rule for logarithms then. Log 10 of 10 is 1, and the power rule means the 2 jumps down to ground level. 2 log 10 of x, that's what we wanted to show. Part 2, show that this can be transformed by a sketch to this, and describe the sketch. So part 2 then, this curve here, y equals 2 log 10 of x. Okay, 2 log 10 of x, which is equal to log 10 of x squared. Now when you add 1 to it, it can be transformed to this. And this, by part 1, was equal to log 10 of 10x squared. So this can be transformed then to y equals log 10 of 10x squared. So we've got essentially y equals log 10 of x squared. And the other one is this one here. Now the question says, show that this can be transformed, which it can, and describe the sketch. So what happens here then? Let's have a look at it then. This is y equals log. I want to write it in the same form as this. So it's log 10. Instead of 10x squared, 10 lots of x squared, I want to write this as root 10x all squared. Now it looks in form akin to what this is, and we can describe what happens. Now if I had log, let's look at something simple. If I had log x as a function and log 2x, what happens here, for example? Well, when the input is 1, we get log 1, but for the output of log 1, I need an input here of x equals a half. So the input 1 here moves to a half, doesn't it? And if I put input of 2, which is log 2 clearly, now the log 2 value happens when x equals 1, so it's as though the point here, this input point, moves back to here, this input point, for the same output. Okay, so that's what happens then. So here, instead of x and 2x, we've got x squared, obviously, but the x is the variable, variable, and this is root 10x. So instead of 2, it's root 10. So instead of it being a half, it's going to be 1 over root 10. So that was just to help us see what was happening in simple terms with an illustrative function. So here then, this is a stretch. So it would be parallel along the x-axis, so it's parallel to the x-axis. By a factor of, so remember that if it was x to 2x, it was a half, by a factor of half, but this is x something squared to root 10 of x, so it's 1 over, instead of it being 2, it's 1 over root 10. So that's part 2 done then. We've looked at that. Part 3, this cuts this at P. Given x value is positive, find the gradient OP. So let's find the x value of OP then. Y equals 1 plus 2 log 10x, which we have here is log 10 of 10x squared. So here, part 3, So here, log 10 of 10x squared then is equal to, so just replace this part here, is equal to log 10 of x squared plus 1. So let's see what that implies. If the logs are the same, then the values themselves are the same. Move the x squared over, we get 9x squared equals 1. And that tells us that x squared is a ninth. Okay, so square root both sides. X is equal to plus or minus the square root of 1 over 9 is a third. But it said something about, given that the x value is positive, so x is a third. Find the gradient OP. So there's the x coordinate of OP. Okay, so now what is the y value? Also, the y value is equal to 10x squared, so it's log 10 of 10x squared. X squared is 9, so it's 10 times 9 is 10 over 9. Log 10 of 10 over 9. So at P, which has x coordinate 1/3, and log 10 over 9, gradient OP is equals, okay, so I think I've got the P. Find the gradient OP log 10a over b. So what have we got here then? We've got the increase in y. The gradient OP is equal to the increase in y then is log 10 of 10 over 9 and over the increase in x, which is a third. So that's equal to then the 3 swings up is 3 log base 10 of 10 over 9. Use the power rule for logarithms. Log 10 of 10 over 9 cubed, which is log 10 of 1000. 10 cubed is 1000. 9 cubed, 9 nines are 81, 7 eighths, 9 eighths is 720, so it's 729, isn't it? Type it in the calculator if you need to.